What I thought I'd do is do some worked examples for some of the ones in cross-topic review, exercise 3, the mechanics from book 2. This is question 14. So if you want to find that and read that, it's the one we got 2 particles, 2 kilograms and 4 kilograms, attached by a light string over a smooth pulley. This one's at rest on a rough surface in equilibrium. This one's hanging at rest. Now the question starts in doing a particular way. I don't think I'd be able to go any further than this in the question without putting some forces on the diagram. So, weight, connected by a string, so there's a tension. Because that's smooth, that peg there, the tension's the same at both ends of the string. So if the question asks why is the tension the same, it's because it's a smooth peg. This surface was on a surface, so there's definitely a normal reaction. And because the surface is rough and this tension wants to pull it that way, there's a friction acting that way. All right, part A. Can we find the tension in the string? For A, it's in equilibrium, working vertically, those two forces are equal. And in this exercise, G is 9.8. So that's 19.6 newtons. Part B. Draw the forces acting on particle B. I might have filled it in there, but on the exam, always put your working next to the section of the question you're answering. So, acting on B, there is a normal reaction, which is vertical. There is a frictional force, which is horizontal. It has a weight, which is vertical. And there is this tension acting at 30 degrees. And we know that tension is 19.6 newtons. Part C. Show that the normal reaction is 22.2 newtons. Right, how are we going to do that? The normal reaction acts vertically. We know the tension, we don't know the friction. For B, it's in equilibrium, working vertically. There are two forces acting vertically, T and the normal reaction balanced by 4G, and T works that way, so it has an effect that way, and it has an effect that way. This component touching the angle is cosine 30. So putting that together, we get that R is 4G take 2G cos 30. Let's work that out. So 4 times 9.8 take 2 times 9.8 times cosine of 30, 22.2 newtons as required. Good. The final part of the question, find the least possible value of the coefficient of friction, the least possible value. Least possible value of mu corresponds to least possible value, the smoothest the surface could be. Well, that'd be if that is just on the point of moving. If corresponds to what we call limiting equilibrium, i.e. the frictional force here is equal to mu r. Limiting equilibrium on the point of moving. If it's on the point of moving, friction is mu r. So we want mu. We know what r is. Oh, so mu will equal friction over R. We know what R is. Can we find friction? For B, let's work horizontally now. Friction equals T, that green component, sine 30. So that's 19.6 times a half, 9.8. Therefore, mu will be 9.8 over, so that's the frictional force over R, the 22.2, which is 0.441. Right, I'll do a few more videos of the cross-topic 3 ones as we go along.